Hi, everyone, and welcome to Module 11. I'm your professor, Dr. English Dowdell. So far, we've worked with variables, loops, decisions, and arrays to handle data while a program is running. But what happens when the program ends? Everything stored in memory disappears. That's where file processing comes in. This week, we're going to learn how to store data permanently by reading from and writing to files. Now, when you think about it, almost every program you use interacts with files. A game saves your progress, a website stores login information, a budgeting app saves your transactions. File processing makes all of that possible. Now, by the end of this lecture, you should be able to explain the basic ideas of file input and output, write pseudocode that shows how to read and write data files, and then discuss how data is stored in files and later retrieved. And this is important. You'll also be ready to complete your file input-output assignment, where you're going to write pseudocode to read student names and scores from a file and then show how that data flows through your program. So let's get started with the basics. When we talk about file processing, we're really talking about two directions of data flow. File input, which is reading data from a file, and then file output, which is writing data to a file. Think of it like this. Input brings data into the program. Output sends data out of the program. So when we use files, we're storing data on the disk instead of just in memory. That means that the data can still be used, the next time that the program runs. So for example, imagine that you've got a file that has it's called student text, okay? And it looks sort of like this: Alex, 85, Jamie, 92, Taylor, 78. Now, each line is a record, and each record has two pieces of data. It's got a name, and then it's got a score, separated by a comma. Now, the file can be opened by a program. It can be read line by line and processed to display or calculate results. Now, whenever we deal with file input-output, we usually follow five main steps. It's called the file processing life cycle. So let's go through each one of these one by one. Now, before we can read or write data, we need to open the file. Now, opening a file creates a connection between your program and the data stored on the disk. So in pseudocode, to read the file, we might write something like open and then students.txt for reading. Now, if we were writing to a file, instead we would say something like open students.txt for writing. Now, this tells the program what file we're working on and how we plan to use it. Now, once the file is open, then we can start working with it. Now, usually one line or one record at a time. And this is where we use a loop. So think of a file as a list of records, and the loop goes through each record until it reaches the end. So in pseudocode, it might look something like this. While not end of file, read line from file process data, and then end while. We'll explore what process data means in a minute, but this is your loop. Once all the data has been read or written, then we need to close the file. Now, closing the file is like hanging up the phone after a call. It ends the connection between the program and the disk file. It also ensures that all the data has been properly saved and resources are freed. So we do that with close file. That's the pseudocode. Now, if you forget to close a file, you might lose data or cause errors for other parts of your program. Now, sometimes a file doesn't exist, or you might not have permission, say, to open it. So it's a good practice to include some kind of error check. Even in pseudocode, something like this. If file does not exist, then we're going to display the text file not found. or else then we're going to get ahead and open the file for reading and do all of that processing and everything else and close the file. And then we do an end if. Now, this isn't required for your assignment, but it is good habit to develop for real world logic. Now, if we were writing to a file instead of reading one, the process would be similar, but we'd send data out instead of reading it in. So we would open the file for writing, we would write the data, and then we'd close the file. So here's an example of pseudocode for that. Open, and then whatever the text file or whatever the file is that we're wanting for writing. And then here we're actually writing the data, and then we go ahead and we close the file. That's all there is to it. It's very simple, structured, and powerful. Okay, so let's go step by step through your assignment example. We have a file named, say, students.txt that contains this data. So what we want to do is we want to write pseudocode that's going to open the file, read each line, split the name and score, display them, and then close the file. So let's build it together. So we start by opening the file for reading. So that's open students.txt for reading. This sets up the connection. The next step is we need a loop so that we can go through every record in the file. So we write something like, while not in the file, read line from file. And then we'd have like our processing data here, our processing procedures here, and then end while. Now, each line is going to look like it is here on the left, Alex, 85, Jamie, 92. We can split the line into two parts, okay, before and after the comma. So we use the pseudocode that says split line by comma into name and score. So this means that the variable name would store Alex and the score variable name would store 85. Now, let's pause for a minute and talk about something really important when it comes to reading lines, and that's delimiters. Now, a delimiter is simply a character that separates one piece of data from another in a file. So in our example, the comma is the delimiter. Okay, so when we read the line Alex, 85, the comma tells the program where the name ends and where the score begins. Now, if there was no comma, then the program would have no way to tell that Alex 85 altogether is actually two separate pieces of information. Now, sometimes files use other or different delimiters, like it may use a tab, semicolons, or even spaces, depending on how the data was saved. So, for example, for a comma separated, like what we have Alex, 85. If it was tab separated, it would be Alex, and then it would have a tab in between and 85. Or we could even have something like a semicolon separator, Alex, semicolon 85. Now, when writing pseudocode, it's important to note which delimiter your file uses because your logic for splitting the line is going to depend on it. So in our assignment, we're using comma delimiter or comma separated files, which often is referred to as CSV. That means is short for comma separated values. Now, CSV files are one of the most common formats used to store data because they can be opened easily by programs like Excel or Google Sheets or even databases. So remember, always identify what delimiter separates your data before you try to process it. Otherwise, you might end up reading incorrect or jumbled information. Okay, now getting back to our steps, we can show the information to the user at this point, and that's where this display name scored plus score. Okay, this is going to produce output such as this. Okay, Alex scored 85, Jamie scored 92, Taylor scored 78. And then finally, we close the file to finish our program by close and then whatever the name of file is. So this is the full pseudocode together. Okay, that's it, your basic file input logic. Now, as I mentioned earlier, optionally, you can add an error handler. So this is what that would look like. Now, even though this is optional for your pseudocode assignment, it's still best practice to include basic error handling in logic design. Now, the second part of your assignment is to create a diagram that shows how data moves through the program. Think of it as a simple flow map. We want to show what happens from the file all the way to the output. Okay, so let's break it down. So you're going to have a start. This is going to be where the program begins. And then open file, the file students.txt is open for reading. Okay, you're going to have that loop structure. It's the while not end of file loop. That's where that begins. Then you're going to have a read line. So one line is read from the file, such as Alex, 85. Then you're going to have some temporary variables. The line is split, remember, into two temporary variables. You're going to have a name and you're going to have a score. So for instance, the name would be Alex. For that example, score would be 85. Then you're going to show in your diagram the process and output. And this is the program, what it's going to display. Then you're going to show a repeat loop. And the loop is going to go back and read the next line until the file ends. And then you're going to have a closed file. This is where the data is processed and the file is closed. And then you'll have an end, and this is where the program finishes. Now in your diagram, I want you to make sure that you label each part clearly. Your input file, which is going to be students.txt, your loop structure, your temporary variables, which is name and score, and then your output display. Now you can use arrows to draw data moving from one part to the next. Now, if you're creating this digitally, Draw.io or Google Slides is going to probably work great. Even PowerPoint, okay? Just use simple boxes and arrows. Now, if you prefer, you can sketch it on paper, label each part, and then upload the picture or the drawing. Now, keep in mind when you create your data flow diagram, I want you to use standard flowchart symbols so anyone reading your diagram can understand it clearly. So in the course room, I've provided a quick reference to help you choose the right shape and know what each one represents. Now, before you start, here's a few common mistakes to avoid. One is forgetting to close the file. Always remember to include the close file step at the end. Another mistake is not using loops. A file can have multiple records, so don't forget the while not end of file loop. And then another one is processing before reading. Make sure that you read the line before trying to process it. Another mistake I see is unclear variable names. Using meaningful names like name and score, not something like X and Y. And then another one I notice is missing the comments. Add comments in your pseudocode to explain what's happening. Remember, it starts with // So, open the file that contains student data or // read and process each record. Now, if you're doing the extra credit, you'll write a simple Python version of this logic. Okay, so here's a sample for you to kind of look at and study. So we go ahead and we open the file for reading. Okay, and then we read each line in the file. So that 4-line in file. And then we remove any extra spaces and new line characters. We'll split the line by commas, okay, and then display the results, and then of course close the file. So this one you can study, but I'd like for you to be able to write something on your own. Okay. Now, if you try this, just make sure that your text file students.txt is in the same folder as your Python file. Okay. So that's it. You'll earn 3 extra points, and then you'll get practice writing working code. Okay, so let's review some of the things we've learned in this lecture. Okay, file input and output allows a program to save and retrieve data permanently. We use the open process close pattern. Now, to read a file, we'll open it for reading, use a loop to read each record, process the data, display the results, and then close the file. Now, you'll apply all of these steps in your assignment by writing clear pseudocode and creating a labeled diagram that shows how data moves, say, from the file to the program and then finally to output. Now, remember, pseudocode is just plain English language. Don't worry about syntax or indentation. Focus on showing your understanding of the process. Now, before you move on, I want you to take a minute to think about this. Have you ever lost data because you forgot to save your work? Maybe in a document, a spreadsheet, or a game. That's exactly what file processing solves in programming. Without files, every time a program ends, your data disappears. With file processing, you give your program memory, the ability to remember information between runs. Okay, so that wraps up our Module 11 lecture on file input and output. So this week, your task is to write pseudocode that reads students' names and scores from a file, and then create a diagram that shows the flow of data from file to input. Now use the sample data provided. Keep your pseudocode structured and easy to follow, and don't forget your comments. Now, if you'd like a little extra challenge, try the optional Python version to see this logic in action. Other than that, enjoy your week, and as always, happy coding.